What if I told you the most devastating disasters in history weren't always caused by massive bombs, deadly earthquakes, or billion-dollar failures, but by tiny ordinary objects worth less than your morning coffee? A single screw, a small valve, a ring of rubber no bigger than a bracelet. These cheap parts should have been harmless, so common and insignificant that nobody imagined they could bring down a city, sink a ship, or end human lives in seconds. But history has a cruel sense of irony. Because when a tiny flaw meets the perfect storm, whether it's freezing temperatures, a raging fire, or human negligence, that insignificant part becomes the trigger for catastrophe. Today, we're diving deep into 10 real disasters where a small, inexpensive component caused unimaginable destruction. These aren't legends or urban myths. Every event you're about to hear actually happened, backed by reports, news headlines, and eyewitness accounts. And I'm not just talking about money lost. I'm talking about lives, about moments frozen in time where everything could have been different if someone had just spent a few more dollars on safety. This is the top 10 deadly disasters caused by cheap parts. Number 10, DC-10 Flight 191 crash, 1979, USA. It was a clear day in Chicago, May 25, 1979. American Airlines Flight 191 was preparing for a routine takeoff, a DC-10 aircraft bound for Los Angeles. Passengers chatted, flight attendants checked seat belts, and nothing seemed out of the ordinary. But hidden beneath the aircraft's smooth exterior was a deadly flaw, the cargo door latch system. It was a small metal locking mechanism, cheap to manufacture, far cheaper than the engines or wings, but designed with one critical weakness: it could fail if not closed perfectly. That flaw had been noticed before. In 1972, a DC-10 over Windsor, Ontario suffered a near disaster when the same type of latch blew open mid-flight, causing the cabin floor to collapse. But instead of replacing the design entirely, the airline implemented only minor adjustments, saving money, but leaving the fundamental weakness intact. On Flight 191, the cargo door failed again, this time during takeoff. The rapid decompression tore through the aircraft's hydraulic lines, sending one of its massive engines ripping away from the wing. Eyewitnesses on the ground saw the horrifying scene. The plane tilted sharply, its wing dipped, and in seconds, it plunged into an open field, erupting into a fireball. All 273 people on board were killed instantly, the deadliest aviation accident in U.S. history at the time. The cost of the latch, a fraction of a percent of the aircraft's price. The cost of ignoring it, hundreds of lives, and a permanent scar on aviation safety. Number 9, the Mexico City oil spill, 2010, Gulf of Mexico. April 20th, 2010. On the Deepwater Horizon oil rig, 41 miles off the Louisiana coast, the night was calm until it wasn't. The rig was drilling one of the deepest oil wells in history. When something went wrong, pressure readings spiked and crude oil began surging upward. Normally, the blowout preventer, a massive safety device, would clamp down, sealing the well instantly. But inside that huge machine was one small, cheap part: the shear ram blade. This blade, designed to slice through steel drill pipes in emergencies, was stuck. The manufacturer had cut costs on upgrades, leaving the blade unable to close in certain pressure conditions. And that night, those exact conditions hit. The preventer failed. A gas explosion ripped through the platform, killing 11 workers and igniting a fire that burned for 36 hours before the entire rig sank into the Gulf. For 87 straight days, millions of barrels of oil gushed into the ocean, creating the largest marine oil spill in U.S. history. Environmental damage stretched for years. Fishing industries collapsed, coastlines turned black, and BP paid over $60 billion in fines and settlements. All because one inexpensive blade failed to do its job. Number 8, Hartford Circus Fire, 1944, USA. It was supposed to be an evening of joy. On July 6, 1944, thousands of families packed under the big top of the Ringling Bros and Barnum and Amp, Bailey Circus in Hartford, Connecticut. Lions roared, acrobats soared, and children laughed, But above them, the tent's canvas was coated in a deadly mixture, paraffin wax and gasoline, a cheap way to make it waterproof. Nobody thought about how flammable it was, until a small flame, possibly from a dropped cigarette, touched the fabric. The fire spread in seconds. The wax coating melted and dripped like napalm, trapping people in a panic. Tent poles collapsed, exits clogged, and within 10 minutes, the entire structure was a blazing inferno. When the smoke cleared, 167 people were dead, most of them children. It became one of the worst fire disasters in U.S. history, and all because of a cost-cutting decision to use a cheaper waterproofing method. Number 7, Apollo 13 Crisis, 1970, USA. April 13, 1970, 56 hours into NASA's Apollo 13 mission to the moon. Astronaut Jack Swiggert's calm voice came over the radio. "Houston, we've had a problem here." Inside the spacecraft's service module, an oxygen tank had exploded. The culprit? A thermostatic switch, a small, inexpensive component in the tank's heating system. Due to a design oversight, it couldn't handle the 65-volt power used during testing. The heat fused its contacts shut, leading to catastrophic overheating and ignition of the oxygen. The blast crippled the spacecraft, knocking out power and forcing the crew to abandon their moon landing. What followed was a desperate fight for survival, rationing water, improvising CO2 scrubbers, and slingshotting around the moon to return home. Miraculously, all 3 astronauts survived. But NASA spent months dissecting the incident, concluding that a cheap switch, costing just a few dollars, nearly killed a crew and destroyed a $375 million mission. Number 6, the Boston Big Dig ceiling collapse, 2006, USA. It was just another summer evening in Boston, July 10, 2006. Traffic moved steadily through the Ted Williams Tunnel, part of the city's massive Big Dig highway project. A $14 billion effort that had taken decades to complete. But hidden above the smooth concrete walls and bright tunnel lights was a deadly weakness. The bolts holding up the tunnel's heavy concrete ceiling panels. Each bolt was secured with a special epoxy adhesive, a material chosen for its low cost and quick installation. It was a decision that saved thousands of dollars during construction, but came with a dangerous flaw. Over time, under constant weight, the epoxy could slowly lose its grip. That weakness had been noted in earlier tests. Engineers had seen signs of creep, the gradual slippage of the bolts under load. Yet no full replacement was ordered. The tunnels opened to the public, with tons of concrete hanging overhead. At 11 p.m. that night, disaster struck. Several ceiling panels, weighing more than 20 tons, suddenly broke free and crashed down onto a passing car. The driver, 38-year-old Milena Del Valle, was killed instantly. Her husband, who was driving, barely escaped with his life. The investigation found that the epoxy holding the bolts, costing just over $1,000, was the root cause of the collapse. The repair bill? Over $54 million, plus a permanent stain on the Big Dig's reputation. A tiny saving on materials, paid for with a life, a fortune, and the trust of an entire city. Number 5, Fukushima nuclear disaster, 2011, Japan. March 11, 2011, a 9.0 magnitude earthquake struck off the coast of Japan, unleashing a massive tsunami. At the Fukushima Daiichi nuclear power plant. The seawater roared over protective walls and flooded the backup generators that powered the plant's cooling systems. Among the submerged equipment was a cooling system valve. A small, inexpensive part that was never designed to withstand complete submersion in salt water. And when it failed, the cooling process came to a halt. Within hours, reactor cores began to overheat. Hydrogen gas built up and exploded, and the blasts blew apart the upper floors of the reactor buildings. Over 150,000 people were evacuated, and radioactive contamination spread across both land and sea. The valve's failure wasn't the only cause of the disaster, but it was a crucial link in the chain that made everything worse. In the aftermath, Japan's nuclear safety regulations changed forever, but for Fukushima, the damage was already done. Number 4, Titanic's rivets. 1912 North Atlantic. The unsinkable Titanic was 4 days into her maiden voyage when she struck an iceberg in the freezing North Atlantic. The collision ripped open her hull, and within just 2 hours and 40 minutes, the giant ship slipped beneath the waves. Investigations decades later revealed something shocking. The iron rivets used in parts of the bow were of substandard quality. To save costs and meet tight deadlines, builders had chosen iron with a high slag content, which made the rivets brittle in freezing temperatures. When the iceberg struck, these weak rivets snapped more easily, allowing the steel plates to separate faster than they should have. Over 1,500 lives were lost in what remains the most famous maritime disaster in history. And it all happened faster because of the failure of cheap, flawed rivets. Number 3. New York City blackout, 1977 USA. On July 13, 1977, a severe thunderstorm hammered New York, triggering lightning strikes on key power lines. Normally, the automatic protection systems would have rerouted electricity instantly. But that night, a faulty relay, a small, inexpensive device, failed to operate as it should. Within minutes, the entire city was plunged into darkness, and for the next 25 hours, New York descended into chaos. Looting, arson, and street violence broke out. Over 1,000 fires were reported, and police made more than 3,700 arrests. The blackout caused economic damage in the hundreds of millions, but the relay that failed cost less than a single dinner in Manhattan. Number 2. Minneapolis Bridge collapse, 2007 USA. August 1st, 2007, evening rush hour traffic crawled across the I-35W bridge over the Mississippi River. Without warning, the center span gave way, sending dozens of cars, trucks, and buses plunging into the water below. Investigators later discovered the cause. Gusset plates, small steel connectors that join beams together, were too thin for the bridge's load. These plates cost relatively little to manufacture, but for decades they bore the entire weight of traffic and repairs. When one plate finally failed, the entire structure followed. 13 people died, 145 were injured, and the collapse shocked the nation into re-examining the safety of its infrastructure. Number 1. Challenger Space Shuttle disaster, 1986 USA. January 28, 1986. The world watched live as Space Shuttle Challenger lifted off from Cape Canaveral. Just 73 seconds into flight, the shuttle broke apart in the sky. The cause was traced to an O-ring, a rubber seal in the right solid rocket booster. Costing just over $1 and designed to prevent hot gas from escaping between booster segments. On that freezing Florida morning, the O-ring became brittle and failed, allowing hot gas to leak and ignite the external fuel tank. The shuttle was destroyed, and all 7 astronauts aboard were killed in a tragedy broadcast to millions around the globe. What made it even more devastating was that engineers had already warned about the O-ring's poor cold weather performance, but those warnings were ignored. A bridge held together by a thin steel plate, a chandelier suspended by a single hook, a billion-dollar spacecraft doomed by a rubber ring. What ties all these disasters together isn't just tragedy, it's the eerie reminder that the smallest parts can have the biggest consequences. We tend to think of danger as something massive, huge explosions, towering waves, unstoppable storms. But history keeps teaching us the same lesson. Sometimes it's the overlooked details, the cheap parts, the shortcuts, the good-enough fixes that set the stage for catastrophe. And here's the most unsettling part. As technology advances and our machines grow more complex, the number of small components increases. Each one is a potential point of failure. Each one could be the next O-ring, latch, or rivet that changes history. So the next time you see a simple screw, a piece of wire, or a tiny seal, remember, size and cost have nothing to do with impact. Because in the right or wrong circumstances, that little piece of metal, rubber, or plastic could bring down far more than you'd ever imagine. Which of these disasters shocked you the most? And do you think we've truly learned our lesson, or is the next cheap part catastrophe already out there? Feel free to share your thoughts in the comments, and don't forget to like, subscribe, and share this video with others.